You can't possibly be a creationist and be an effective researcher, be a scientist. Is that really true? Well, we're going to talk about that. Is Genesis really an asset to science instead of a liability? And I will try to convince you that it is. There's so many wonderful things to study. This is a big a fossil, you might say, like a reptile. It's a reptile, about this long. Beautiful creature, lives. It hangs on my wall in my office. And then we have all these rocks. Now, I mentioned the beautiful green things, but actually geologists don't like all that green stuff. We like the western United States where there isn't all that green stuff covering the rocks. You can see the rocks exposed beautifully. And I think, God made Utah and Arizona and those places for geologists. You don't have the green stuff covering up the rocks. So let's talk about this possibility of Genesis actually being an asset to science. Okay, the goal of science is to discover facts about our world. One of the goals of the book of Genesis is God tells us some basic facts about origins. Now, to a lot of people, they don't like those two ideas. They don't fit together in their minds. This involves human wisdom, discover facts about our world. In the book of Genesis, God tells us some of those facts, and that's divine wisdom. Okay, so for many people, that's a conflict. These two don't fit together. We don't like somebody telling us how it all happened. We want to figure it out. But can we turn that around and make that mutual support between the human wisdom? Yeah, we do have to use our wisdom. We have to do things that we can understand. But can we combine these with these to come up with a better result? Back up just a little bit and look at the foundations for science. Human wisdom alone. That's the philosophy of naturalism I talked about. No creator. You leave the creator out of the picture. Or you take a different foundation, divine wisdom, and we believe that God maybe knows more even than we do. Can you imagine that? That he knows more than we do. And he knows about creation, the fall, and the global flood. Okay, and when we're studying ancient history, that's when the question of conflict or mutual support is most pertinent. And when we're studying ancient history, studying origins, we're studying physiology. You got animals living in your lab. You can study them, how it works. But when we're studying what happened in the ancient past, that's a little more tricky. And I've mentioned these different philosophies. Conventional science, I would say, has a handicap because it's building on an uncertain foundation. In fact, I think a false foundation. Whereas science founded on Genesis has an advantage. It's building on a true foundation, the foundation of creation plus the flood. And when we're studying science, there are two major steps, and it's important to understand these two steps. We ask questions, and then we seek answers to the questions. Okay, and that's important when we look at how we do that in studying the past. The questions. If we have a correct foundation, it can result in better questions. If we take God seriously, I'll try to convince you it can result in asking better questions, developing better hypotheses. But then we go to the answers. God gives us this general framework of the flood, the catastrophic flood. But he doesn't give us a lot of details. He left a lot of things for us to figure out. So when we're looking for answers, we have to then test those hypotheses and use normal scientific procedures. And I'm going to give you an example of that. And so I believe we can come up with mutual support between Genesis and science. Does that really work? And I've already told you, I think, yes, it does work. And my talk right now is to give you an example of how this works. I've been privileged to be involved in several major research projects through the decades, and this is one of them that's been very fascinating. Taphonomy of fossil whales in Peru by myself and Arthur Chadwick, a colleague And here's our group of helpers out in Peru studying these whales. And so what's taphonomy? Well, one way I like to define taphonomy is it's a study of dead and rotting things. Now, that doesn't sound really great, but a little more delicate definition is it's a study of all the processes from death to fossilization. Why do some things get fossilized and others don't? Why do some skeletons get preserved complete like this, and why are some other fossils just broken pieces of bone? There's always a reason why, and that helps us to understand these processes. Okay, so some of us were down in Peru, and we were introduced to this Pisco Formation. You see all these layers. You've already learned about layers of rock. These layers used to go all the way over to the Andes Mountains, but a lot of it's been eroded away. And so this formation is along the coast of Peru, all these greens. The Andes Mountains are over here, and the ocean is here. So here we're looking from the place where the whales are over to the Andes Mountains. The only green things here are where the rivers come out of the mountains, and that's where the people live. But we look for the fossils up here in these dry places. And if you're familiar with the geologic column, this formation is right up here in this upper part of the geologic column. Now the Atacama Desert along the coast of Peru is the driest place in the world. Driest place. I've seen an official figure of 1 millimeter of rain per year on average. And you can see there's nothing here. This is the one plant you find out there up on the higher hills, but this is a very unique plant. You know, if you're walking along on a trail and you see a turtle, you can pick up the turtle and look at it and put it back down, no harm. We usually don't do that with plants, but you can do that with this plant. You can pick it up and look at it, put it down. There are no roots. There's no point in having roots. There's no rain. There's nothing for it to find in the soil. This plant can live here because up on the higher hills there's a mist that comes in off the ocean in the morning and waters it, and that's how it gets its moisture. But otherwise you see what it's like. Geologist's paradise, nothing to cover up the rocks. And there are beautiful fossils in this formation. Shark teeth with the whole skeletons of sharks, penguins, dolphins, many things, but we focused on the whales. A whale is a huge creature, has a very big skull, the vertebral column, the ribs, and the flippers, and that's what it has. And we find lots of whales, and they're relatives of these whales that live today, including the blue whale. And here's a fossil whale. So you have this huge skull, and the vertebral column going back, and the ribs, and the flippers are all there. And here's the way they often look when you find them in the desert. The wind and the weather takes away the covering and exposes them, and they start to break down, fall apart. But it's all here. The skull is there, the vertebra, the ribs, everything is there. And so they're fascinating to study. And we did a focused effort on them. This is my colleague with a very precise GPS system. We would locate every whale where it was, and we could map it rather precisely. And when you do that, you find out an amazing thing. There are whales by the hundreds, actually. And if you look at the whole picture, by the many thousands. But here's our first research area. This is an aerial photograph of looking down at the hills, and every dot is a whale, a fossil whale. Now I've got them described here as complete whales and partial whales. The partial whales are because modern erosion has damaged them. But the evidence indicates these were all really pretty much complete whales. And here in about roughly a square mile, you've got 360 whales. What's going on? Anyway, you just don't find 360 whales in 1 square mile. And if we look at the same hills from the side, you see that the higher you go up on this hill, the more abundant the whales are. Down this upper part, you got about 350 whales per square kilometer. That's a lot of whales. And they're in sediment, which is mostly diatom skeletons. diatomite. These are microscopic organisms that live in the water. They have these beautiful little silica shells. If you have a swimming pool, you probably have, your filter probably is diatomite, which is this stuff, because these delicate silica things make a very good filter. But they're by the untold billions of these diatoms. Okay, when we got there, we learned immediately that there were beautiful whales, and we studied the literature and found that the accepted picture, the accepted scenario, is that this sediment accumulated a few centimeters or a few inches thick per 1,000 years. That's the way it happens today in the ocean, in the deep ocean. And so it's been assumed that that's what happens over millions of years. This formation is believed to have taken about 12 million years. Okay, but then also we have these well-preserved whales. So, question we asked is, how fast were the sediment and the whales deposited? Can such slow burial preserve complete whales? Now, this has been studied for 20 years by geologists and paleontologists, very good scientists, and they all thought that they knew how long this took, 12 million years. Okay, we didn't come with that assumption. We asked, how fast do you have to bring the sediment in to deposit this? And our hypothesis of whales were buried much faster, because it doesn't fit this very slow burial and complete whales. If you got a whale, these whales are up to 50 feet long. If you got a whale this big, and you're burying it this much for 1,000 years, how long is it going to take? Tens of thousands of years to bury a whale. Well, what happens in the modern world? We all have to look at what happens today and compare it with what happened in the past. But we have to have our eyes open and see it clearly. Okay, here's what happens today. And there's people who study this off the coast of California. When a whale dies, it sinks to the bottom, and think of how much food that is. That's just a fantastic food supply now for animals. And by the thousands, they descend on this whale. And within 6 months or less, this is what it looks like. Flesh is gone. And then the next crew comes in and starts working on the bones. Chewing holes in the bones, digging into the sediment to get the oil that's leached out. And within a few years, that whale is gone. So tens of thousands of years, that's really not possible. So that's the modern world. That's what happens today. Now how about the ancient world? Thousands of years to cover this? Well, it's all there. And even, whales have this baleen in their mouth, a filter-like material. And it's not bone. It's more like your fingernails. And in today, that doesn't last very long when a whale dies. But here we have fossilized baleen in the mouth of the whale. And many of them have baleen preserved right there. We published a paper on fossil baleen, and up to this time, there were, in all of the museums in North America, there were about a half a dozen examples of fossilized baleen. Well, we published a paper with 31 examples, and then we've discovered many more since then. So this is the baleen preserved, indicating very rapid burial. And these diatoms, look again at them. In the modern world, the diatoms die in the ocean and they settle slowly through the water. By the time they get to the bottom and get preserved, only about 1% of it gets preserved. It gets dissolved in the water. But look at our diatoms. They're beautiful. They're totally preserved. They haven't been dissolved. This needs an explanation. So, sediment, a few centimeters per 1,000 years, well-preserved whales and diatoms. How can that be? Well, we focused on the whales, and this is one of our favorites. This is the skull, and the rest of the whale is here, and this is a full mouth full of baleen in place. Beautiful whale to take our picture with. And here's another whale, there's another whale, another one over here, and they're just all over the place. So what was going on? Well, we excavated whales to look at the details. This is one we named Carmen, and when we found it, this was the only part that was exposed above the surface. So you see it's damaged, by erosion. But we uncovered the rest. The bones are all there, beautifully preserved. This flipper is complete along with the finger bones. But there's something wrong here. This flipper is just gone completely. So what happened there? Well, we find shark teeth associated with these whales, including shark teeth as big as my hand. And in some cases, find a shark tooth with the point embedded in the bone of the whale. So there's been a lot of scavengers rapidly removing flesh and leaving these beautiful bones like they are. Here's a huge one. It's all there, wonderfully preserved. Here's an interesting small one. That's about 2 yards long, 6 feet long. Every bone in place. It has the baleen right here. And you notice the orange color. Okay, this is the way the sediment looks. It's whitish, this diatomaceous sediment. The orange color you only find right around fossils. And that's because they still had flesh there when they were buried. They were buried with at least part of the flesh still there. And the decay of the flesh sets up a chemical environment that causes this color to be there. Again, another indication of how fast these were buried. Here you see some of the bones, and when you look in detail at the bones, they haven't been chewed on by organisms. There just wasn't time for any of this to happen. And here's this is one of our favorite whales. Show you a picture of him pretty quick. But a slab of this baleen came out of its mouth and landed on top of a flipper. So we're going to take a close look at that baleen. This is the one we called Fernanda. There's a crew excavating it, and here's Fernanda in all its glory. Every bone there, except for a couple of the end of the vertebrae, the tail vertebrae. Every bone there. And we looked at a couple of details here. This is that slab of baleen, and I'll come back to that in just a minute. But first of all, let's look at a vertebra right in through here. We took out one of the vertebrae and cut it in half. And so right here, enlarged here, that's where the spinal cord was. Now, if you've ever studied anatomy, spinal cords and brains, that's kind of mushy stuff. You wonder, how does that work? Soft tissue. But here is the reason this is black, because that spinal cord was still there, was buried, and the decay of the spinal cord set up chemical reactions that deposited a lot of heavy minerals in here. Again, another indication, very rapid burial. And so now let's look at this baleen. Here's a close-up, and you cut cross-section through here, and this is what you see. The dark, those are these slabs of baleen. The white is the diatom sediment in between it. And right here, you see the surface of one of these layers. And here it is enlarged, a microscopic view. That's the baleen, that's protein. Okay, 12 million year old protein? I don't think so. This is soft protein, and I sent it to a lab back east, Mary Schweitzer, who does this kind of study. She identified it as protein, still there, and I don't think it took 12 million years. Had to have been not very long ago. And these whales, they didn't get beached and then die on the beach. These whales all died in the water and then sank in shallow bays. And later that was raised up when the Andes Mountains came up, and so it's above sea level now. But here's an example of how this works. Here you have the huge skull and the rest of the whale, and this skull is sitting back partly on top of the rib cage. Okay, a whale skull is very heavy. I don't think the little water currents there are going to raise this skull and lift it up on top of the rib cage. So what happens, apparently, these animals die and they're floating on the surface, and then they begin to sink, and this whale here, like the Titanic, broke in two parts, and the skull settled down, sitting on top of the rib cage. And so this gives us insights into what was happening with these whales. And so what killed them, and what did they get buried with? Well, they're in all this diatom material. And diatoms and other floating plankton, if they're in the right condition, they'll rapidly reproduce. These planktonic blooms, red tides we call them. And when they do that, all this diatom material creates toxins in the water. And here we have something called marine snow. This is diatom skeletons. In enormous amounts from these blooms, a rapid reproduction of these diatoms. And it's so much of it in the water that it looks like this. And so the whales apparently died from probably two things. The toxic diatom blooms, red tides, and there's been experience here in California in 2000 illustrated that those toxins from diatom blooms do indeed kill large mammals. Sea lions were killed, and they traced it to these toxic diatoms. But also, one of the reasons you have so much reproduction of diatoms is because of a lot of volcanism. As the Andes Mountains are forming, you get a lot of volcanic ash, and that ash has minerals that the diatoms need. Okay, but also, volcanic ash has a lot of very sharp glass shards in it. It's not a good idea to breathe all that stuff. Okay, so breathing volcanic ash and toxic blooms is probably what killed the whales. And then ocean currents and storms brought them and concentrated them in these bays. So, summary of the evidence. Complete whales, bones in pristine condition, the baleen preserved, the diatoms in pristine condition, but the theory is slow sediment deposition. All right? There's a conflict here between evidence and theory. You just can't have tens of thousands of years to bury these whales and have them be preserved. It just isn't going to work. And so why did no one else notice this? Why us? Well, there's a very good reason why. Because the others think they know how long this took. And so they're not asking questions like, how fast did this happen? They're just not noticing these things right in front of them because like I say, they think they know the answers. But we look at it from with a different eyes, with different thinking, and so we thought of questions that others did not think of. They did not have the motivation to dig deeper, to look closely, to figure this out. But we had the motivation, and it worked. It showed us, it gave us new ideas, and the data supported our ideas. So a false worldview can lead to false conclusions. The false worldview can blind us to conflicts between the evidence and interpretations. And that's what had happened. These other guys were not poor scientists. They were very good scientists. But they were working under a wrong worldview which just didn't lead them to the right questions. Okay, a true worldview can give us an advantage. I read a lot of the anti-creation literature. And one thing is very obvious to me. Those guys have basically no understanding of how an educated creationist thinks. They know their worldview and only their worldview. Okay? I have an advantage. Not because I'm smarter. I'm sure that's not true. And they have certainly more resources. But in order to be a creationist and do research, I have to not only know what the Bible says, I have to know everything they know. I have to read the literature. I have to know as much as they know. And so I have to know their worldview plus mine. So that gives me a very distinct advantage which they don't understand. They only see it from one worldview. I look at it, my friends and I are all the time comparing these different points of view and thinking to ourselves, where can we test between these? And so that gives us a very distinct advantage. And it gives us a broader base for asking questions and interpreting evidence. So it opens our minds to notice conflicts between data and interpretation and to ask new questions and suggest new hypotheses. But the Bible leads us to ask these new questions. But I don't see anything in the Bible where it talks about fossil whales. God has given us a framework, the creation and flood framework, but now He left it to us to figure out the answers to our new questions. And so we have to use normal scientific procedures, how we collect our samples, what instruments we use to analyze the rocks, and all those we use normal procedures. And so when we do that and do it carefully, it works. And if we do careful work, we can actually get it published. This is an article in this is the most prestigious geology journal out there. And they took our article with our whale on the cover, and this article directly addressed the question, how fast do these whales have to be preserved, have to be buried? And our evidence from the fossil whales told us it had to be buried very fast. And we got that published. And actually, it was a very interesting process. We first of all gave a presentation at a paleontology meeting in Europe on taphonomy. And there were a couple of the best taphonomists in the world were there, and we were hoping we could meet them. Well, it turns out because of the leaders of this conference didn't communicate very well, we didn't know how big our poster should be for our research. And so we had posters several times bigger than they're supposed to be. But they looked at them and they said, oh, we'll definitely put those up. So they gave us, the others had a 1 meter square poster. We had 2 posters, 3 feet high by 7 feet long. And they gave us a big place to put these up and told us to keep them there during both of the sessions, poster sessions. So the first session for an hour and a half, there were a lot of people around our posters, and then they drifted off to the others. And these 2 people we wanted to meet came down, and we had an hour and a half with them. And they said, they were enthused about our work. They said, yes, your evidence supports your conclusions. These had to have been buried very fast. And so our conclusions, the numerous fossil whales were well preserved. They were not beached, but they sank in shallow water. And that requires rapid burial. And so all of this had to have been deposited several orders of magnitude, like 1,000,000 times faster than has normally been thought. And it was an interesting thing happened when I was writing this paper. The evidence to me said you had to bury each whale within days to weeks. But I thought, they'll never publish that. That's just so different. And so I softened it a bit and I said months to a year or a few years. Well, one of these top taphonomists was actually a reviewer of that paper. And she came to that part and she said, no, your evidence says it has to be faster, days to weeks. So I put that back in and we got it published. Toxic blooms and volcanic ash killed many vertebrates, and the currents brought this all and concentrated in these bays, and the things were buried very fast. So a biblical worldview combined with careful science can result in improved scientific research. And this is just one example I've shown you. There are others that we've done through the years and other people have done. Every time this approach has been used, it has led to improved understanding and data that actually fits better with the Bible. So it's exciting doing this research, and it's very rewarding. And God has allowed me to do this for many years, and it's been exciting. So that's just one example of how, if we take the Bible seriously, it can give us better science. Now I'm going to spend just a few minutes telling you about some resources. This book called Faith, Reason, and Earth History. This is the 3rd edition of this book. It's a textbook, but it's understandable to anybody who has some science background at least. And it's as far as a book that tries to take a comprehensive look at this whole issue of origins, this is certainly the most complete one. And this 3rd edition is much updated from previous editions. And the church has a committee called the Faith and Science Council, which meets twice a year, to plan how our church is going to reach out to the world and to our students with these issues about origins. And they sponsored this book. They helped cover the cost of publishing. So you can buy the book, but you can download the digital copy free anywhere in the world. They wanted it to be available to use in our institutions anywhere around the world. So you can just go online to Google and you type in Faith, Reason, and Earth History. And it'll give you a couple of different places where you can download it free. And so that's a great asset for our work, our educational work around the world. And like I say, to get this, you just go online and type in the title, and it'll give you places where you can get it. Here's another book, a little one, Choose You This Day, Why It Matters What You Believe About Creation. So that's this one over here. This one isn't available free, but it's just a couple bucks, so you can afford that. Why it matters what we believe. And then I really want to communicate with various groups. And so I've been working for the last few years on other publications. And there are actually 5 more books coming out. These 4 have been already accepted for publication by the Pacific Press, and this one's being considered at the Andrews University Press. And the Faith and Science Council wants these to be available, and so these are also going to be available free, online. They'll be available in 2019. This one, Creation Really, it's written as a conversation between a creationist and an atheist. They're on a long geology field trip, and they have this series of conversations. And so I'm hoping it's one that some people will read who wouldn't bother to look at our other stuff. This one, Where is the Evidence? This is based on this series of PowerPoints that I'm showing you, plus some others. So that's a very concise summary of where, this one, where is the evidence going? And it's going in a direction that's actually very encouraging. This one, God, Science, Friends, Do You Know Jesus? For years I've been giving talks to Junior Sabbath School at Azure Hills every month. And this has grown out of that. It's basically the gospel in stories, with part of it being dealing with creation. And I worked with a co-author who took my stories and put them in a context of a conversation between 2 kids and their uncle. And so, hoping this can be helpful. This one is Jesus is My Partner, Adventures of an Intrepid Fossil Hunter. This is adventure stories from all this research in Peru and Wyoming and many places through the years. And so, and it's with enough, so the adventure stories to get people's attention with enough faith and science woven in to get my point across. And this is answering criticisms of evolutionists saying you can't be a creationist and do research. And there are good answers to those criticisms. So those will be available next year if you're interested in more material or know somebody who would be. So again, thank you very much. And I think we're going to have some questions.
I think one of the reasons why I invited you, Dr. Brand, was because I read parts of your book, Faith, Science, and Reason. Is that the title? It's right here, Faith, Reason, and Earth History. And I was just impressed at how you treated the other side. You were just very respectful towards the other point of view, and you alternated your chapters between how the evolutionist would look at the evidence and how the creationist would look at the same evidence. And I found that to be a very respectful way, but also a very convincing way. Because like you said in the first presentation and in this, your presuppositions affect the way that you look at the information. And just to see the way in which your presuppositions affect how you examine the evidence is really interesting. So I would really recommend this book here. Yes, we want to open up the conversation. If you have any questions, please raise your hand and I'll bring the microphone over to you.
About a decade ago, researchers, principally at Purdue University with an assist from an emeritus applied physics professor at Stanford University, found that radioactive decay rates for 3 widely spaced elements in the periodic table change over time. Silicon 32, radium 226, and manganese 54 change in 3 ways, with changing Earth distance from the Sun in its elliptical orbit, with the occurrence of solar flares, and with the 33-day rotation of the Sun's own core. Question: isn't it true that the evolutionist geochronologists also don't really understand radioactive decay and so radiometric dates?
Well, I think they don't, and none of us do. They think they understand it well enough to use it. And actually, they have to have it. And even if tomorrow we found that that radiometric processes are completely, our interpretation of them are completely wrong, they'd still have to have basically the same time scale to account for evolution. But it's true, these points you mentioned are very intriguing to me, that the distance, as the distance between the Earth and the Sun changes, the decay rates change. Okay, that the distance from Earth to the Sun doesn't change very much, so it's not enough to answer our overall question. But it tells me that those decay rates are not intrinsic to the elements. They are affected by outside factors. So that tells us that there probably are answers that we can look for. But they need the time scale, so they're not going to give it up.
What was the elevation of the whales in Peru, and what is the connection between diatoms and diatomaceous earth?
Okay, the whales, that whole coastal area where the whales are goes from sea level up to about 1,500 feet. So it was deposited in these shallow bays, and as the Andes Mountains came up, that has been raised up. And the connection, diatomaceous earth is just all this sediment, which is mostly diatoms. That's what diatomaceous earth is, and they use that for filters.
I think you might have answered my question. I noticed in one of your pictures there, the diatomite, the beds, or the deposits appeared to be bedded in several layers. And I was wondering if the whales were found in a certain one of those layers or throughout the deposit.
No, those layers, there are many layers, many more than you saw in my picture. And the whales are spread all the way down through. So, yeah, so there are, if we could dig all this up, there will be many thousands of whales. I mean, it's just, this formation goes for 200 kilometers, and there's just, I don't know how there could be so many whales.
I'm not sure where I've heard the explanations that creation scientists, and I believe I heard an explanation from Robert Gentry, but other videos and things that I've watched try to explain from a creation standpoint why the radiometric dating is inaccurate, and a lot of times they use lava flow into the ocean, and they take different samples that have been submerged versus samples, that are from the same lava flow, and they show how it was many years difference in age. So are these explanations not really that valid either, as to contradict the reliability of radiometric dating?
Well, yeah, actually the dates don't always come out like they should. So there are problems in their point of view. And you're talking about the submerged potassium argon is changing from potassium 48 to argon, which is a gas. And if the rock forms underwater, the water pressure prevents the gas from escaping like it should. So there are things like this that say different parts of it don't work very well. But there isn't, so we have intriguing things out there, but we don't understand it well enough to really say, yeah, we know what's wrong with it. So we have guessed, we have some clues, but there's a lot more we need to know.
Yeah, the whales in the pictures all appeared to be laying in their normal upright position. Is there any significance to that, and were they all in that same position?
Well, when we actually look at them, and we took a lot of careful notes on that, some are upside down, some are right side up. So apparently that part doesn't matter. But that they died and sank to the bottom. There were a couple of cases where it sank, but it was more like this, which again tells me it probably, how are you going to have a whale sitting like this? Probably kind of a rapid process, and it was surrounded by sediments quickly, so it didn't settle down flat.
Sorry, one more question. In your example of the grand staircase erosion model, the layers are there very distinctive. Is it possible that tests are taken maybe hundreds or even thousands of miles away, that you can identify, oh, this soil came from that mountain 800 miles away? Is there any way you can correlate those sorts of things, or?
Some of this work is done. Yeah, they look at sediment here in this rock formation and try to figure out where it came from. And to some extent, you can do that. And sometimes it's quite surprising. Like there are huge sandstones in the southwest. This one that I showed you, the Navajo sandstone, in one of those steps in the Grand Staircase. Geologists have traced that sediment, that sand, back to the Appalachian Mountains. I mean, That boggles my mind, but and so yeah, to a certain extent you can do that, but not always.
How would a single catastrophe establish these different rock layers? Right? How would it separate out the types of rocks?
How would it separate out? Well, and we've never seen a global catastrophe, so we don't fully know the answer to that. It had to be, like say, one layer of sand must have come in from one place, and probably the next layer of something else came from a different direction. So that kind of thing can be happening. And also, flowing water will sort the sediments according to the particle size. And there are intriguing trends you see, like in the Grand Canyon, you see something you find around the world. The first, at the bottom of the Paleozoic, which is what I think would be the beginning of the flood, you have a kind of a coarse sandstone. Then right above that you find mud. Then above that you find limestone. Okay, water will sort things so the heavier things will come out first, and then lighter things, and so on. So that fits. And you find other places where you find this kind of sequence. And so, but we don't know all the answers to how it all got sorted out into these distinct layers.
I was just going to ask, when you present your ideas to an evolutionary person, do they see any logic in it? How do they respond when you do logically explain these things?
Well, it depends on the person. I don't really get invited often to present this to evolutionists. But tomorrow, actually, I'm going to tell you a couple stories of specific examples of how, if I happen to be talking to a person who's somewhat open-minded, I can have very interesting conversations. A lot of others would just think I'm nuts, So it depends on who you're talking to. But at Loma Linda, in our geology program and biology program, we have a number of people who are doing research, and we often will work with people who are atheists or whatever. And we find a trend, that is, whereas they would normally think we're nuts, when they get to know us and see how we do research, even though they may really wonder about our ideas, that they respect us. So that's been a trend.
Just a little bit further, I know there's a lot of Christians now that believe in evolution. So are they, like maybe God created it over millions of years, that it wasn't just 7 days creation. Then are they more open-minded? Or maybe you don't speak with them as well. I don't.
No, they're not more open. They're more likely to be the opposite.
Is that right?
Yeah, I'll talk more about this tomorrow. But yeah, the Christian world in general, at least the scholars and the leaders, are going completely to theistic evolution. God created by evolution over millions of years. And they're often very antagonistic to people like us. They don't like us. I can't help thinking in some cases it might be a guilty conscience, but anyway.
Just out of curiosity, in your adventures as a fossil hunter, have you spent any time in the John Day fossil beds or in Oregon's Fossil Lake?
I actually haven't. I'm aware of it. I was up there once, but I haven't researched it. Great place.
I'm just curious about when you did a weird research and it got published in the Geology Journal. Isn't that all the evolution scientists also see those journals? So you are speaking in front of the evolution scientists, and how do they respond to that?
Yeah, the thing is, okay, so you got this formation that's quite, hundreds of feet thick and believed to be deposited over 5 million years, 12 million years ago. And so we showed that these whales had to have been very, very fast. And I know that the whales are spread all the way through this formation. So to me, it raises doubts about the whole thing. But when you publish in an article like that, you can't really say that. I could not prove that this whole thing was deposited so fast. So they'll probably think, well, yeah, you buried this whale fast, you buried this one fast, but you had sediments in between that must have taken a long time. So they'll always find a way to fit it in. But having studied these things and knowing how many of these whales there are and how well they're spread, I think that isn't going to work. But if I tried to say that, I'd never get it published. So you try to get your evidence out there, and hopefully it'll get people thinking about it.
Yeah, we really appreciate you taking the time to explain these things and share all the years of knowledge that you've acquired. Let's end with a word of prayer. Dear God, thank you that we're able to be here. Thank you that we're able to learn. And we just want to pray that you would help us tomorrow to put even more pieces together in the puzzle so that we can see the bigger picture. Thank you for the fact that we have this opportunity, and we just praise you for your goodness. In Jesus' name, amen.